Hi, this is Chris. I'm here to talk about trigonometric functions. This is from the Mathematics for Machine Technology book, Unit 60 by Robert D. Smith. I'm an instructor at Shoreline Community College. We use trigonometric functions to determine angles. If you have the length of any two sides of a right triangle, you can determine the angles of the triangle using one of the trigonometric or trig functions, sine, cosine, or tangent. Given a right triangle CDB, angle C and angle B can be determined given the length of any two of the sides, A, O, or H. For the trigonometric functions, the three sides are labeled O for opposite, A for side adjacent, and H for hypotenuse. And they depend on which angle you're working with, at least the two, opposite and adjacent. The hypotenuse, here shown in blue, is always the longest side, the one that's opposite the right angle. The adjacent depends on the angle. If we're talking about angle C, the adjacent is on the side that forms one side of angle C. That's line CD shown in green. Once again, the hypotenuse is always the longest side across from the right angle. If we're looking at angle B, now the names of the sides switch. Angle A, the adjacent, is now line DB, forming a side of angle B. When we choose the function we need to work with to determine the angle, it will depend on the values you have to work with. Look at the bubbles below. Which values do you have in your problem? Side opposite, the sine and hypotenuse. Side adjacent, we use the cosine and the hypotenuse. Side opposite and side adjacent, we can use the tangent. We choose the function depending on which values, side adjacent, side opposite, and the hypotenuse that we have to work with. Let's take a look at the sine function. The formula for sine function is sine of C, angle C, equals the opposite over the hypotenuse. So if we have the length of the two sides, the opposite shown in green and the hypotenuse shown in blue, we can determine the sine of angle C. So given that the hypotenuse is 2.236 and the opposite is 2 in this case, we plug those numbers into the equation. The sine of C equals 2 over 2.236. This gives us 0.89445. This is the sine of angle C. We look up this number on the sine table or using a calculator, look it up on the calculator, and this tells us that the angle is 63.44 degrees. The sine function, we can use a bubble and to help us with the sine function. Looking at the bubble, we see that if you have the sine or the hypotenuse, you can think of the side opposite as being divided by the value of either to find the missing value. If you don't have the side opposite, then you need to multiply the two values on the bottom, the sine and the hypotenuse, to get it. So the sine of the angle times the hypotenuse equals the side opposite. Let's look at the cosine function. Its formula is the cosine of C equals the side adjacent over the hypotenuse. So if we have the length of the two sides, side adjacent and the hypotenuse of 2.236 and the side adjacent of 1.0, we can determine the cosine of the angle C to determine the angle C. So plugging these figures into the equation, we find that 1 over 2.236, or 0.4472, is the cosine of the angle C. We look this up in a table and it shows us that the angle C is once again 63.44 degrees. So the bubble is a shortcut to helping us use the cosine function. It shows us that side adjacent above can be divided by cosine to find the hypotenuse. It can be divided by the hypotenuse to find the cosine, or if you're missing the side adjacent, you can use the cosine times the hypotenuse to find the side adjacent. Now let's take a look at the tangent function. The formula for the tangent function is the tangent of the angle C is equal to the side opposite over the side adjacent. So here, if we have the length of two sides, the opposite and the adjacent, we can determine the tangent of the angle C. We plug the adjacent side of 1.0 and the opposite side of 2.0 into the formula to get tangent equals 2.0 divided by 1.0, which gives us 2.0. Now if we look up the tangent of the angle C, we find that the angle C is 63.43 degrees. So the bubble, once again, is a shortcut, helping us to use this tangent function. What it tells us is that we can find the side opposite if we have the tangent and side adjacent by multiplying them together. We can find the tangent if we have the side opposite and side adjacent by dividing the side adjacent into the side opposite. Similarly, we can find that the side adjacent if we have the side opposite and the tangent by dividing the side opposite by the tangent to find the side adjacent. And when we don't have the side opposite, multiplying the two on the bottom, the tangent and the side adjacent, we get that answer. Thanks for joining us with us. I hope you enjoyed it. Bye.